Hello, as Benjamin said, I'm working for Global Logic, and today I'd like to show you what we did with Eclipse Cura and Mosquito, but it's not the only thing we work. So I'm a software engineer working as architect right now. For last 5 years or 7, mostly in embedded field, doing industrial automation, embedded things. And I'm the only Java person among C, so pure C developers. What you see here is like our start, what we did. So we are running water. Because we have quite good experience with industrial networks, industrial communication, and also have knowledge about the domain of flow meters and other equipment, we decided to expand our knowledge into the IoT and industrial IoT things. So we decided to create a little test bed just to have a place or environment to create demo applications, case studies that we can share with our customers. Because we are mostly service providers, we don't have our own products, we are doing things. So, PA and PI, what is it? PI is process automation, PA is process instrumentation. It's the ground base for all big factories, installations. And our approach is to connect sensor and actuators or controllers to the cloud. Most of the time, those devices are connected using non-Ethernet connections. So there are Modbus, hard or Profibus. Mostly this is serial connection or even analog one. We thought that our target is not to connect IoT or cloud services with big distributed control systems or SCADAs because they are closed or they are for safety reasons or other things. So we decided that we want to focus only on connecting single devices or single installations controlled by some PLC. And so we need to connect in easy way to the cloud. This is our requirement. Possibility to have edge computing because we want to be very close to the data which are generated. For example, to provide some safety features or provide some maintenance tasks. And we not want to disturb existing systems. So, requirements for our test bed, our demo scenario is we want to measure something physical, something that we can touch, feel. Sometimes it causes problems. We want to use industrial grade equipment. So we don't want to play around with some like simple flow meters or simple Arduino thing, but want to have real industrial equipment. We want to be as close as possible to process instrumentation setup. So we want to have our measurement scenario needs to be as close to the real industrial process. Yeah, easy for the demo, easy to understand, and not too expensive. This is a quite big thing because most of the time those systems tend to be very expensive. So, and of course safe and secure. We are using SSL and TLS provided by Mosquito or Cura or other cloud things. So, for measuring water, we are using flow meters that are available on the market. You can buy them, and they tend to don't have Ethernet connection. So it's very hard to connect them, for example, to the Cura gateway or to the other things. So we need to create some kind of intermediate system to connect them. Those flow meters, the data model of them is based on the registers. This is the Modbus protocol specification, and it's not really modern, right? It is based on Unit 16, and all other data types are reflected in based on 2 bytes. So you need to convert your, for example, float value from 2 bytes. So what we realized, this is our setup. I think it is the quite early stage. We decided to use PLC to have like a front end before all other things. So we have the pump with an inverter to have water flowing. We have some flow meters, some temperature sensors, and some pressure sensors. And the PLC acts as a front end, as an industrial front end to them. Additionally, we have some local HMI and some lights. And now I want to tell you a little bit about IoT architectures. This is like the general concept. So we can imagine that we have one device which is directly connecting to the cloud. For the flow meter or other industrial sensor, it is not the case because we cannot connect to the internet from such device. We need to use a gateway or a router or also some access device, which is the second from the top on the left-hand side. And this, in this scenario, we are directly connecting using serial connection to the, for example, flow meter, and using the gateway device connect to the cloud. The other 2 are like mesh computing, mesh networks, which is not the case for my scenario. So we end up with such concepts. We want to have it nice for demo, so or for small talks during conferences or fairs. So we created a mobile application and a simple realization of the cloud, and of course our application based on Eclipse Cura as a gateway. Which technology we used? So because for gateways, the most common way to realize gateways is based on Linux. So we decided that single board computer based on Linux will be the appropriate one. For this particular demo, we are using Raspberry Pi, which is not really good for industry, as I said, but for demo purposes, it's okay. We have now experience also with industrial Windows 10 based system, which we need to adapt a little bit of the Cura source to run there. But other Linux-based single computers will be good also. We choose Eclipse Cura because it's OSGI-based. I'm a fan of OSGI, so that's was the main reason. But it gives us out of the box the possibility to connect to the cloud, to connect to the serial device, and even manage the network infrastructure. And MQTT is used as a transport protocol between gateway and the cloud solution. For the cloud, because when we were doing that, Eclipse Capua, the Eclipse IoT's cloud solution was not ready yet. We decided to write the simple Spring Boot application that listens to the MQTT messages and expose the REST API. This is the whole picture of our system, the flow. So on the left-hand side, you can see the sensors, which are connected using different protocols to the PLC. PLC is aggregating them, and those 2 blocks on the left-hand side, they're like a abstraction of the real industrial installation. Of course, very simple in this case. And in the middle, the IoT gateway is connected using Modbus protocol to the PLC, the most common, very old one, but really right now used everywhere. And this IoT gateway is pulling data from PLC. So it's pulling, for example, the flow value. And then it is forwarding this data to the cloud. At the cloud part, we are using Mosquito just for simple realization. And the mobile application on the right-hand side is connected to the REST API and is showing the data. Why Cura? Cura provides a really good abstraction of the hardware for Linux single-board computers. It allows you to write applications in a modular way based on OSGI and provide additional features like connection to the cloud, for example, to the Eurotech, I don't remember how it's called, the Eurotech cloud, or to the Kapua. Recently, that there are connectors to the Microsoft Azure, I think IBM Watson, and Amazon FOS, I believe. Also, Cura provides with a really good network management. So if you would like to establish the secure connection or to start with your local network really fast, it allows you to configure everything from the configuration UI. Additionally, for my purpose, Eclipse Cura is bundled with the Modbus field protocols bundles, so it was very easy to start communicating with, for example, this PLC. Okay, so I want to really focus on that, maybe on the hardware where Eclipse Cura can run. It can be easily run on any kind of Raspberry, I think besides Raspberry Pi Zero. It runs on BeagleBone, Edison, so in general on any Linux-based embedded computer, but also on the Windows-based. It is not official release, but if you are a developer and really can dig into the code, it is quite easy to have it running on Windows machine or on the Windows computer. We are right now in the phase of providing some services to the customer based on Windows machine. Yeah, what are the benefits from using Eclipse Cura, Mosquito in our scenario? So it reduced complexity. So if you can imagine that you want to send data to the cloud, you need to think about many things. For example, the protocol, security layer, some caching mechanism, reconnecting mechanism. This all is provided by Eclipse Cura, by this framework. OSGI provides you the modularity and dynamism to your application. So your application can be split into some modules which can which can start and stop at any time. So if you design your application really quite well, this mechanism gives you really a lot of benefits. For example, the configuration of registers, so the addresses of the data which you want to pull from the PLC, they in our case, they are realized as modules using whiteboard patterns. So at any time I can deploy another set of configuration data, and it will be in the running system, it will automatically pull them. I don't need to restart my gateway. Easy development, so there are it is plain Java with some additional metadata, and it's not real hard to start developing. On the contrast, if you will choose, for example, plain C or C++ for a gateway, it will increase the complexity a lot. Yeah, we did it really fast. It was like a couple of weeks of work. And potentially it gives you a possibility to have a very fast time to market. And the learning curve is really smooth. I had like 3 interns in our company, which were like C embedded developers, and they wanted to learn something new. And in a week time, they start like having some bundles running in Eclipse Cura. Yeah, it can run potentially everywhere where Java is running. So I want to give you some short demo. I have 5 minutes. So those are screenshots from application we are controlling, our demo. Those are really only right now if my application want to run on the handy. So on the left-hand side, you can see the status of our system. And all the data can be, all the data are shown here. You can expand each section and give some additional data. And you have the control screen also. No, not questions yet. First, I would like to show you some, I don't know if we have sound here. So, can you hear? Oh. Okay, so. It is maybe on the different screen. Okay. I think it will be good. Yeah. So, this is the video showing how this whole system is starting. So from the application, I started the inventor. So right now I'm increasing the frequency of the inventor, so increasing the power of the pump. And you can see that the water is flowing. And right now you will see like an overview of the system, the pump. There is a pressure sensor, but it's not needed. Here is the first flow meter. The green cable is a Modbus cable to the PLC. The second flow meter a lot of cables. It's not an industrial installation, but this is the local HMI, which shows the data, and all those data are available to the Cura, and Cura is forwarding them to the cloud. In the Cura, we are using Cura payload, so using the Google Proto Buffer, and yeah. And we've got some lights, and when the red is running, everything is stopping, and we've got some emergency stop here. Yeah, okay. Maybe I'd like to show you some code if I have like 2 minutes more. So, sorry, this is Visual Studio. Sorry, Eclipse. But it's fast for me. So, we've got a lot of imports. This is the code of one OSGI bundle, the component, simple flow monitor. I'm using the BND tools to annotate Java classes in order to generate OSGI metadata. Right now, I assume that maybe you have some knowledge about OSGI. I won't go deep into the specifics of OSGI. But it's quite easy. For Cura, we need to have Modbus service available, cloud service, and cloud client. So we are declaring methods that will inject Modbus service here, and also the cloud service and OSGI framework. In this case, Eclipse Cura, which is running on Equinox, will inject those services if they are available during runtime. In activate methods, this is the code which first need to create the cloud client, so the way to connect to the cloud, and then create the polling mechanism and connect to the PLC. So the activate method, of course, disconnect everything, and how we connect to the PLC. So first we need to create some properties. In this case, I'm using the USB converter to the RS485, so it is a serial connection to the PLC, and I need to set some configuration data for the serial communication. And yes, and Modbus service, I set the configuration, and yeah, and that's all. And here is the pooling mechanism. So in the pooling mechanism, I'm using the lambda you saw here before. Where is that? Yeah, here. Here's the runable, which is using this function, pool PV, and I'm using the scheduled executor at fixed rate. Rate is, I think, 5 seconds. So each 5 seconds, I'm running the code which will pull the data from the PLC. And yeah, and pool PV is somewhere here. Yeah. So I've got 2 floats. Let's focus on the water flow. I want to read this water flow, so I need to run this function. Yeah. So if the Modbus service is available and it is connected to the PLC, I'm reading holding register. It is a concept from Modbus specification. So I'm reading 2 registers, because 1 register is 16 bytes, float is 32, so I need to read two registers, 4 bytes in total. And then I need to convert what I read to the float. So I need to shift some data, shift some bytes, and have some casting. And that's all. So I have the water flow value here. And this water flow then in the pool PV, this water flow value is bundled into the Cura payload. It is a concept from Eclipse Cura. The description of the data which will be sent to the cloud. So I'm using the cloud client and publishing the raw metadata with 2 metrics, the water volume flow and the temperature, to the cloud. And then in the Mosquito broker, if somebody is registered to the topic which I'm sending to, can read those data. So that's all. Thank you. And if you have any questions,